Good day, everybody, and welcome to the slow carbon cycle. We're going to go through a couple of different carbon cycles. So they're all part of one big carbon cycle, but we're going to look at different aspects of it, kind of one at a time. So we're going to look at the slow carbon cycle. This is going to be very similar to what you were learning about with the rock cycle. And this is going to include or involve the geosphere, the hydrosphere, and the atmosphere. So let's get right into it. We're going to start with solid rock on a mountain that undergoes weathering. Like I said, exact same as what we were doing with the rock cycle. This weathering, just water, precipitation, something is falling on these rocks, and we are getting the creation of sediment. Stuff is breaking down into smaller pieces of stuff. This is all a physical process. Now, there's another type of weathering. I don't want you to worry too much about it, but just to let you know that this is a thing. There's actually something called chemical weathering, and what happens is the atmospheric CO2, the carbon dioxide in the air, it actually combines with the water and precipitation, and it creates something called carbonic acid. It's a very weak acid, but what it can do is it can break down rock into different ions. So the rock already contains some calcium, magnesium, sodium. These ions are also sort of weathered off of this solid rock. Like I said, we don't need to be too worried about what's exactly going on in this process. Just know that carbonic acid does exist in our rain, and it helps with the weathering process. So right after weathering, we're going to go into erosion. So this is when all of our sediment is using the water systems to start traveling off the mountains, off the solid rock. It can be traveling in the groundwater, it can be traveling in runoff. Eventually, through the waterways, it's going to be getting into the ocean. Pretty much everything ends up in the ocean eventually. So all the little pieces that were broken off by either physical or chemical weathering, they are going to travel from where they were to somewhere else. In this case, we're going to say they are going into the ocean. Now, once in the ocean, this is going to go back to chemical weathering. So like I said, this is just for your information. This is something we're not going to spend a lot of time on. But if you remember those calcium ions that had been weathered off, when they get to the ocean, sometimes they'll combine with the bicarbonate, which is already in the ocean. And this will create something called calcium carbonate. Now, when we're talking about the slow carbon cycle, I'm talking about solid rocks of carbon, a lot of times I'm going to be talking about this calcium carbonate. Just look at that chemical formula and see there's a C in it, which means that there's carbon. This carbon is going to be moving around in this form. So you can get it from ions. This calcium carbonate also is just physically eroded off of the mountains. A lot of times the formation of calcium carbonate can happen in the sort of along the way on the erosion pathway. Sometimes it can happen with just physical weathering. Another thing that happens is we get this calcium carbonate into the ocean. So we get it from erosion, but we're also getting this calcium carbonate from corals and shelled animals. Basically anything in the ocean that has a tough shell or a firm outer structure or exoskeleton, anything that makes a shell, that's going to be made out of calcium carbonate. So it's important that enough calcium carbonate gets into the ocean so that these animals can use that calcium carbonate in order to make their protective shells. The corals and the shelled animals also become a place where this carbon is actually stored for the lifetime of the animals. In the case of coral, that calcium carbonate, that carbon, stays within the bodies of dead coral, which then new coral grow on top of. And so they will keep that carbon within them, sort of hold it in that form, in sort of the skeleton, in their skeletons for a long time until that reef gets physically destroyed. But just like anything, so this is full of calcium carbonate. Oh, sorry. So I wanted to give you a little bit about calcium carbonate in context. This is something you have probably run into. Just straight up calcium carbonate, that's basically chalk. It's the main ingredient in Tums or antacid tablets. As I said, it shells. It's not only seashells, but it can also be in chicken shells, chicken egg shells. It makes up limestone and marble, which is often used in statues and used in some buildings. So when I say calcium carbonate, you can kind of picture these little household items to give you a little bit better context. But back to the ocean, we have our corals, we have our shelled organisms. So when they die, that calcium carbonate is released again. Also, any calcium carbonate coming in just from erosion, all of that is going to sink down to the bottom of the ocean. Now, I'm guessing, once again, just like the rock cycle, you're probably guessing what's coming up next. So we have all of this nice calcium carbonate, just old shells that have fallen to the bottom of the ocean. What's going to happen over time is it's going to get buried. There's going to be another layer and another layer. So sedimentation is happening. All of these layers of calcium carbonate are getting buried together. They're getting pushed together. They're forming sedimentary rock. Now, you can actually see an example of this. If you've ever seen the White Cliffs of Dover in the UK, those are all limestone cliffs. So that is from thousands to millions of years of this layering process happening. The reason that these are cliffs, because a tectonic event sort of brought them out of the ocean where they originally were and shoved them up on land where we can see them. So limestone, you can see sometimes it can come in this bright white color. Also, if you get deep into that limestone, you're probably going to find a lot of fossils. Most of it's going to be made out of a lot of dead organisms. If these limestone deposits do not get, shoved up to the surface again, most often we're going to go back to our rock cycle where these layers of sedimentary carbonate rocks are going to be eventually pushed under, maybe due to subduction, something else. They're going to be pushed down into the mantle, and that carbon from the calcium carbonate is going to melt into the mantle. Now, once it gets into the mantle, it's going to hang out there. It's going to go along with all those convection currents. And there's one way to get that carbon back out again, and that is through a volcano. So when a volcano erupts, that melted carbon is going to come out in the form of gas, in this case atmospheric carbon dioxide. Volcanoes put a lot of smoke and gas and just lots of nasty stuff in the air. A lot of times if there's a volcano, sometimes you can't go on commercial flights. The smoke is so dark, it'll block out the sky. It'll just mess with navigation. So lots of gas is coming out of this volcano. And a lot of that is carbon dioxide. So that's the rocks that have melted are now being transformed into gas. Also, small amounts of carbon are also coming out in the form of lava, which, as you know, is going to turn into igneous rock once it cools. So that carbon's going in, it's melting, and the only way it can come back up in this slow carbon cycle is with major volcanic activity. One thing I want to note, though, so you see on one side, there could be a subduction on one side. If you're tracking, say, one atom of carbon, it could be circulating throughout the mantle for up to 200 million years before it comes back up in a volcano. So this is the reason why we call this the slow carbon cycle. This whole process, the whole cycle is taking such a long time. We're talking geological timescales for the carbon to be on a mountain, to get broken down, to get buried, deep, deep within the earth, eventually so deep that it melts in the mantle, and then to circulate around and eventually come back up in a volcano. So this takes a very, very, very long time. So to review here, our slow carbon cycle, which is a lot like the rock cycle, it starts when we've got solid carbon in rocks. By the way, most rocks have some form of carbon in them. I know I've been talking mainly about calcium carbonate, but in one form or another, you're going to find some kind of carbon in all types of rocks. So that's broken down by precipitation. It could be either physical or chemical weathering. So remember that carbonic acid comes into play. Then erosion happens. These sediments are basically sent away from where they originally once were. They're moving through water. Like I said, everything eventually ends up in the ocean. This calcium carbonate sediment, it collects, usually in the mud, it's getting buried. Sedimentation is happening, sedimentary rock is being created. After a long time, this carbon is buried deep enough. It could be either just buried deep enough, it could go through something like subduction, where that solid carbon is going to melt into the liquid of the mantle. Now that molten carbon in the magma, it's going to circulate for any number of years, could be hundreds to thousands to millions of years. Very hard to track just one single carbon atom circling around the mantle, but you get the idea. These are very slow happenings. Then, upwelling, some kind of volcanic activity is going to happen. That carbon is going to be pulled back up to the surface through the volcano. Most of that carbon is going to be vaporized. It's going to turn into carbon dioxide and go back into the atmosphere. Though some of that carbon is going to leave the volcano as lava and eventually get cooled and hardened into igneous rock. So this is the slow carbon cycle. Once again, it can take up to 200 million years to completely go through the cycle. And this one is going to be very much related to the rock cycle. Now these are all inorganic, these are all non-living processes. We're going to look at the fast carbon cycle next, and that's where we're going to start getting into the biosphere. But for now, that is our slow carbon cycle. Credit to SlidesGo for the lovely template, and please email me if you have any questions. Goodbye for now.